Now, I'm not going to dive too far into 11.2, but I do want to open up 11.2 just to showcase something. Now, you don't think that there's only 5 pages on 11.2. I just woke up early this morning and decided, you know what, we might end up stepping into 11.2. So I want to make sure that I have something for you. So I just have the first 5 pages ready. So nothing huge. But you should have already watched at this point. I know you're prepping for an exam. I totally get it, but the course doesn't slow down for that. Sorry about that. But luckily, most of it's going to be just review. But I want to just spend the rest of today on a single page. This page right here. That's it. So let's talk about series. So the calculus of series. We're going to start actually with a similar definition to what we had for sequences. We had something that said convergent and divergent sequences. Now we have a similar definition, convergent and divergent series. Now here's the important statement that I'm going to spend part of the day on here, part of the rest of the day on. If the sequence, and it should be a singular, if the sequence of partial sums S sub n is convergent, and the limit as n goes to infinity of S sub n exists and is finite, then the series are just infinite sums. The series A sub n, summation of A sub n, is called convergent, and we write that the summation I equals 1 to infinity of A sub I is equal to S. Otherwise, we would say the series is divergent. So that is, if I give you a sequence of partial sums, and that sequence as n goes to infinity tends to be finite, then its series is called convergent. There's a lot of beefiness to that statement, so I'm going to rewind the tape a little bit. When I teach pre-calculus, I try to make a big point of this because I'm assuming that people are in pre-calculus to go to calculus, right? Because you're in pre-calculus. So when I teach pre-calculus, which I do almost every semester, I try to make a big stink about this. Every time somebody hands you a sequence, they're actually handing you 2 sequences. So let me show you what I mean by that. If I hand you the sequence, oh, interesting. Notice how thin my pen ink is. It's because whoever programmed this app that I use, Inkodo, they just came up with an update and it broke part of my pen. All right, interesting. Okay, so if I hand you the sequence that looks like this, I'm just going to make it a nice easy one. 1/2 to the nth power, which by the way is the same thing as 1/2 to the nth. Okay, that's our sequence. Let's just pretend. So if I hand you a sequence, I'm telling you right now, I've actually handed you 2. A sub 1, well, that's just 1/2 to the first. Actually, let's do it this way. A sub n is 1/2 to the n minus first instead. Let's do it that way. So if I do it that way, A sub 1 is 1/2 to the 1 minus 1, or 1/2 to the 0th, or 1. A sub 2 is 1/2 to the 2 minus 1, or 1/2. A sub 3 is 1/2 to the 3 minus 1, which is 1/2 squared, which is 1/4. And you get the idea, I hope. A sub 4 is 1/2 to the 3rd, which is 8. A sub 5 is 1/2 to the 4th, which is 16, and dot, dot, dot. That's the base sequence. Yeah, the 1 in the numerator does have a power of n minus 1. However, what is 1 to any power? Yeah. yeah, it's just 1. So there's no need for me to write it. That's why when I wrote it this way at first, I was like, let me write it this way. It's just a little bit easier. Yeah, no problem. So this is our base sequence. It goes on forever. But here's a second sequence. It's a sequence of what we call the partial sums. And the reason why, while this is in the review video that I put online, I just think it's so important. I need to repeat it here. So a second sequence would be called S sub 1, S sub 2, S sub 3, S sub 4, and so on and so forth. down the line. But what are they? They're the sum of all the sequence values up to this index. In other words, S sub 1 is A sub 1, S sub 2 is A sub 1 plus A sub 2. S sub 3 is A sub 1 plus A sub 2 plus A sub 3, and so on and so forth. This is called the sequence of partial sums. So this is the base sequence. Actually, I kind of like that this guy did, whoever coded this, made my ink kind of thin because it seems to work nicely here. And this second sequence is a sequence of partial sums. So I'll just write that way. Sequence of partial sums. So let's see what that sequence of partial sums looks like. Well, S sub 1 is the sum of the first element in our sequence, which is just going to be A sub 1, which is just going to be 1. S sub 2 is the sum of the first two elements of our sequence, which is 1 plus a half, which is 3 halves. S sub 3 is the sum of the first three terms of the sequence. And at this point, I hope you can see that that's just basically saying it's the sum of the first two terms plus the third term. In other words, it's S sub 2 plus A sub 3. S sub 2 being 1/3, we just computed it. Or I'm sorry, not 1/3, but 3 halves. Plus A sub 3, which is 1/4. Adding those two up, let's see, that's 4, 2, 6, 7 eighths. S sub 4 is S sub 3, the sum of the first three plus the fourth. So that's 7/8 plus the fourth term in our sequence, which is 1/8. Wait. Hold on. 2. Hold on, that's wrong. That's 7/4. Sorry about that. This would be 7/4. Sorry about that. Let me just double check. 6 7/4. Yes. Sorry about that. All right. So S sub 4 would be the sum of the first three, which we've computed sort of incorrectly initially, but then fixed it to 7/4 plus 1/8. Let's see. 2, 14 plus 1, 15/8. And S sub 5 is the sum of the first four terms plus the fifth term. Sum of the first four terms we just computed to be 15/8. The sum of the fifth term, or the fifth term, is 1/16. And this will be, let's see, 231. 31/16. So here we have two sequences when I handed you only one. The first sequence is very important. It's a base sequence. The second sequence is what we are going to be playing with. That sequence of partial sums. The sequence of partial sums leads to what we call the series. So the summation I equals 1 to n of a sub I. Well, that is the nth partial sum. In other words, if I sum the sequence values from 1 to 5, I will get S sub 5. It's right there. But the sum of the series, in other words, the value of the infinite sum, is going to be the limit as n tends to infinity of that summation. I equals 1 to n of a sub I. So we want to know what is the limit of this sequence. Remember, we just finished a section where we said, hey, does this sequence right here converge? In other words, if I went on forever, would it become something finite? Now we're asking the same question for the next sequence related to it, the sequence of partial sums. We're asking, will this limit as n goes to infinity of, instead of calling this the summation I equals 1 to n of a sub I, let me erase this and call this S sub n. And now I'm really asking, hey, is that limit of our partial sums, that limit of that sequence S sub n, is that going to converge? And if it does, what does it converge to? That is all of chapter 11. Starts in 11.2 and it goes 10 more sections. So this is what we are going to be dealing with for the rest of this chapter, a very large chapter of material. Gosh, my ink looks tiny. Crazy. Anyhow, so I just want to make sure I spent a little bit of time talking about sequences, the base sequences, versus the sequence they create, which is a sequence of partial sums. Now, before we leave, I want to remind you, we have an exam. You already know that, on Friday. I'm in the middle of writing it. So right now, I've pared it down from, I think I started with 60 some odd questions. Sorry, I'm yawning. I started with 60 some odd questions. I'm down to 14 right now. That is flexible. It might decrease a little bit, it might increase slightly. It just depends on the problems. I have to go through and do them and time them and all that stuff. But just to let you know, that your exam's almost completely written. And I'm trying to be somewhat fair about what's placed on the exam. The study guide is a really good guide for how to do the exam. There are definitely going to be questions on the exam that are not on the study guide, but they're more concept, like, do you know what you're doing, rather than just, do you know how to compute? So be aware that you do know how, you have to know why things work. I don't know if that's correct, but anyway, you don't just be a computing machine. Okay. Try to understand things too. So anyhow, I think that's about it. So it's 8:50. We have a 10-minute break. And if you're going to join me for office hours, I'll see you there. If not, you have a wonderful day. Everybody have a wonderful day. Study hard. And like I said, see you on Friday for the exam, 7:20. Yay. I'll be back in 10.